We will start in 1 or 2 minutes. And so welcome back to our workshop on exploring the LLM frontier. And today, Enrique will be showing an example how to use Gemini from Google, this large language model that is behind all some of the general AI applications from Google. So this is part of our series. Last week we saw the Phi-3 small language model developed by Microsoft. So today we will review another language model from Google. Okay, let me close this. And we're done with that. Okay. So hi, Enrique. So we will start, as usual, we start going to our main page. Let's see, I have it here somewhere. Our main page for the Data Lab GitHub repository for all our learning resources. This is the address. And so remember that on Thursdays, we have the Exploring the Large Language Model Frontier. And these are the different sessions we have had in the past. So today we will be reviewing Gemini. And Gemini is another large language model, but this is developed by Google AI. And there are several tasks where Gemini performs, like natural language generation, question answering, translation, summarization, recognition. It will recognize objects and text and images. It will understand and recognize images, enabling to parse complex visuals, such as charts and figures, and also can be helpful in code generation, as you will see in today's example. The usual limitations, as other large language models, is hallucinations, probably, some bias, and also it will demand large infrastructure for computing. And here there's going to be a short list on learning resources about Gemini, where you can explore the Google blog, for example, or the Google AI for developers. There's a list of different Gemini models that are behind some of the applications. And also you can find more technical information from Google AI research. And also you will find several models in Hugging Face where you can use them. So we will just jump directly to our today's Jupyter Notebook, and I leave Enrique to the discussion. Thank you for coming.
Hey, thank you, Carlos. Hello, everybody. So let's just dive into the notebook. My screen now. Can somebody confirm it, please?
Yes, we're seeing your screen.
Thanks. Okay, great. So as Carlos was mentioning, Gemini is a competitor product to the OpenAI GPT suite of models. So the way to interact with it is using also a web API client, and it has some similar idiosyncrasies, and we'll get to them. But what is important here, I think, is to make the distinction between what is using an LLM through a provider and what is how do you yes.
Enrique, can you increase a little bit your font, please?
Yes, of course.
Thank you.
But no. Great.
Thank you.
So Gemini is an LM hosted by a provider. The way to charge it is through tokens. We're going to use a specific model, which is the Flash tier that has a free tier. So that means that you can do your own prototype and learn how to use it yourself without having to pay. And then when you're ready to deploy your application, you can opt into adding funds or choosing a larger model for better accuracy. The first thing that we gotta do, oh well, by the way, this notebook is on the repository. It's the Gemini.ipy notebook file. So feel free to borrow it to get some inspiration or bootstrap your own application. But let's get started. So we need to install the client library, which is the Google Generative AI one. We're constraining ourselves to any version that is newer than 0.7.2. It's going to take a little bit. Oh, there it is. So the foundational step is that we need an API key. I already have one configured on my environment. You can get yourself one if you sign into the Google AI dashboard. So once you do that, you save it into an environment variable. In this case, since we're using Colab, we're using Colab's own API to fetch environment variables. So once you do that, we need to configure the library, Google's Gemini library. It is Google.generative AI, but for the sake of this workshop, we're going to rename it to Gen AI. So we need to set what is the API key. And if everything is correct, you should be able to do it. The first step that I like to do always is to do test prompt, just to make sure that everything is configured correctly. As I was mentioning, Gemini is a suite of models. The latest version or major revision is 1.5, and there is a Flash version of Gemini. Flash is the basic one and contains a free tier. Nonetheless, you're going to see that it's quite capable. So you need to create a handle to this specific model. This could be, if you were using LangChain, this could be equivalent to Chat Gemini or Chat OpenAI if it was GPT. But in here, we're just going to call it generative model. It is multi-model, and we're going to see it. So we need to define a handle, and then we can use its API to start doing stuff. So the first test is to get some brief text generated, and what better than asking it to write a haiku about Tucson. So haiku is a type of Japanese poetry that usually contains 3 phrases. So far so good. So we get the response object, and we look into what is the text in it. So desert sun burns bright. Our arms reach for sky. Tucson's heart beats slow. I could say that this is quite appropriate given the geographical context of where we're located. So it is working well. Let's take a peek at what is inside the response. Similar to other providers, the response object is going to have a bunch of metadata besides the text that is generated. We have a flag that tells us if this finished correctly. So usually this is what you're going to see. But it could be that the request is taking a long time. There's a lot of demand on the servers, and it times out. So when it times out, it returns to us, but it's not complete. So the way to check that out is by looking at the done flag. Iterator none. I'm not really sure what this means, but the result one is the main the contents. So there's a generated content response, and in this case, we are just we have a text part. So you need to look into the data structure and find what is the actual text that we want. But there is going to be, as you saw here, there is some syntactic sugar such that you can access the text directly instead of navigating through the data structure. Similar to using conversational paradigms in other libraries, there are going to be two models. One is going to be the user or the human, and the other is going to be the model or the assistant. So in this case, the model slash assistant is the response, and the reason why it finished is because it stopped by itself. So this is good. This is what we want to achieve. Some additional metadata that might be useful for you if you're developing an application is that Gemini includes some safeguards. Safeguards are just flags that tells you whether the content that was generated is sensitive, and it breaks it down by category. So in this case, there's no hate speech, not sexually explicit content, or this other type of um, potentially flag negative content. So the probability of those are negligible. I have not tried to break this or jailbreak it, so I assume that there will be some category here that is highly likely or absolutely likely. But when you're coding it, you can take a look into this and decide whether you want to show it to the end user or you want to censor it to avoid any type of liability. And the last standard type of metadata is, as usual, when you see generative text LLMs, you get the number of tokens that are contained on your prompt and the number of tokens that are contained on the response and the total. So this total should be just the addition of both. You are usually charged by this amount. There's a rate for input tokens and a rate for output tokens that depend on the specific model that you want. This is the Flash one, which is the cheapest one, and we're using the free tier. So that is not relevant for today's session, but when you're building your application, you need to keep that in mind. So some of nice features of Gemini is that it's multi-model. I think that nowadays you could take that for granted with, like Llama just released their own vision model as well, where you can mix prompts in pictures. GPT has had it for a few months already, but at the beginning this wasn't the case. So I'm glad that we're seeing that transition where now an LLM is not just a language model, it's also a vision model, a multi-model one. So Gemini is already tuned to do all sorts of inference. So you can it's behave like an AI assistant in a sense like GPT or ChatGPT does. So one test case is that I looked for an image of a fictitious universe, and this is a screenshot of a video game. Some of you might be familiar with it, but I'm not doing. It doesn't have anything special. It's just perfect characters on a scene. So with Gemini, we could do a visual question answering, and you do that by including your text content as a prompt and passing it alongside the input image. So in the cell above, this one that I am highlighting, we're using Python to load that image, using the Python image library, and we can display it on a Jupyter notebook just for the sake of going through this notebook. But this is what could be encoded. On prior sessions of our workshop, we've seen how to do this manually by running a vision transformer yourself. Since this is a provider, it doesn't really matter. We just need to send the handle of the image and it will be uploaded to Google servers. They'll take care of all the encoding for you. So going back here, I want to see how far we can push Gemini to answer accurately multiple questions about this scene. So I am also giving it an instruction to format the output on a specific format, which is Markdown, mainly because it plays nicely with Google Colab and Jupyter. So I'm setting the context. This is the image that depicts a scene in a recently released video game. So using Markdown as a format, answer the following questions about it and format your output to have a title. So I want to see a code snippet of Markdown that has a main title and then goes and answer each of these questions one by one. So once we define the prompt, we can call the generate content function, which is the same one, the same method that we use to generate the haiku. But notice now that we are, instead of passing a single variable that contains a prompt, we're passing a Python list that contains the prompt and the image. So when we make reference to the image in the prompt, Gemini will already consider the image as part of the context. And let's just call it and display the results. Okay, so the first thing that I want to notice is that this was like really, really quick. There was some overhead time by sending the image to the server, but in reality, like when you're processing images, it requires a lot of GPU, so it takes time. Since this is hosted by Google and they have infinite compute power, they can implement it really quickly for us. And let's see how well did it follow the prompt. So the title could be Star Wars Jedi Fallen Order, which it's sort of accurate. So yes, there's a video game called that contains these characters, but this is from the sequel. This is Jedi Survivor, but that's okay. So the questions that I ask are of different nature. So let's go one by one. How about reasoning? So how many characters do you see? We're asking the LM to can something using language. So the result is 2, which is great. So it passed the first test. How does the background scene looks like? So we're increasing the complexity here. It features large rocky cliffs with a hint of greenery on the slopes. The skies have length of blue and orange, suggesting a setting sun. So I'm just gonna scroll up a little bit and make sure that that's accurate. And yeah, I could say so. So we definitely have the rocky hills. There are some bushes around, and there are some. I probably you could say there are some patches of grass alongside the bushes and the short trees. And I could certainly say that this is during the evening. So that was quite impressive to me. Impressive to me. So I like that. Um, so what is the fictional universe in which this scene takes place? And this is the Star Wars universe. So right, what I didn't explicitly reference that. Um, the only way to tie it in is by saying that this is a recently released video game. And this implies that Gemini already has a lot of background content baked in. So I'm pretty sure that it has seen footage and images about this game before because it's able to fetch an arguably correct title, and it understands what's the fictional universe where it takes place. And finally, we're asking it to describe the scene with detail. So this is akin to image captioning. It's just generated a textual description of the picture. So the scene shows a man with red hair and beard wearing a brown and gray jacket, sitting on a rocky surface. Uh, I so I guess that's sort of accurate. We cannot see where exactly he is sitting, but it would be safe to assume that it's a reasonable guess given the background. He appears to be looking toward his right side, where a small white and red robot with green lights is positioned. Yes, that is true as well, and so on and so forth, right? So um, I could say that this was a successful test, and Gemini has some advanced image understanding and question answering capabilities. But what if we want to process something that it's not necessarily images? We could also do PDF files. So for that, uh, we are going to upload a PDF file, but you give me just a moment. I need to fetch that file. I forgot to upload it. I'll show it to you in a second. Almost there. Bear with me. So I'm uploading the README. So this is a copy of our workshops, a README or landing page. So I'm gonna see if I can open it here. Well, why don't I show it to you? This is it. So I'm pretty sure that if you're here, you've seen this. So it is just the outline of the workshop. So we are going to upload the file by just pointing it to the file path and giving it a display name. You're going to be probably charged by, depending on the amount of bytes. Since this is a simple, small PDF file, I don't think that this will get any meaningful. Probably at some point you'll get charged 1 cent, but that should be okay. So we are storing the contents of the PDF on Google servers, and we get a handle to it. So we know what is the URL. So in case you want to download it, download the updated copy, you get the URL. But the important thing is that we get a handle to that file. So then we can start asking questions about it. So this is similar to what RAG does, but the managing of the vector databases is done for us, so we don't have to worry about it. That's the trade-off that you do. You decrease the complexity, but you have to pay a monetary price for it. So what if I want a summary of the document as a bulleted list in Markdown format that has title and subtitles for each of the sections? Let's see what happens. So what this is doing is that it's actually opening the PDF file, getting out the textual contents, and generating the summary. So this is a bulleted set of bullet lists that contain the different main points. We have the calendar, and yeah, we're here. So today is October 17th. So it's able to accurately get that and explain what are we doing today, including text code, audio, and images, and what is coming up. So I'm excited about these two next sessions. So hopefully you can join us. But as you can see, this is pretty much the same thing that we did with the image, but now the file is a PDF file. So this multimodality goes beyond images and audio. So it also gets different formats of text files. And something that could be really important is, or not important, but interesting would be to see if like the PDF contains an embedded image. If we could ask something about that image, I didn't try that myself, but that's something that you could do on your own. So this is one example of a task called summarization. But what if we're doing an extractive question answering? So let me just go back here to this page, summer. At the bottom, yeah, there's a footnote who says who wrote and who updated to this PDF. Well, let's see if we can instruct Gemini to pick this up. Who wrote this document and when? So this document was created on July 18th and updated on July 19th by Carlos Lizarraga. So let's just go back and verify if that is accurate. Yes. And as a matter of fact, it says c.lizarraga. So somewhere else it spells out the first name completely. So it is able to tell out like what does C stand for in c.lizarraga, which is pretty cool as well. It might look like small potatoes to you, but I think it's pretty neat. So the multimodality, yes. So there's a free 1 million token hour Gemini Flash access. So arguably, we could dump I don't know if you could use a Harry Potter book, but the complete documentation of, I don't know, fast API or Hugging Face transformers should be able to comfortably fit within that 1 million token hour. So that is one of the marquee features of Gemini, the long context window, and that is really useful because it is easier to do RAG when you have longer context size, but there's always a trade-off because it is harder to direct the LLM to the desired location. So there are some, the way these are trained, sometimes they pay more attention to the beginning and the end of the documents than to the middle, especially if they span long. But that's a topic for another session. Yes, this definitely fits academic papers and journal articles, probably whole journal issues as well. So what about the flagship feature of LLMs, chat? So Gemini supports chat conversations where these, and I'm going to tell the model. So in this case, I think that Gemini doesn't support system prompts. So we're going to tell it what it is with a user message. So you should always do user message, model message, user message, model message, and so forth. Otherwise, it's going to crash. So let's role play with Gemini that the LLM is a physics professor holding office hours for graduate students, and it's going to greet me. So it's going to ask me how can it help me? And I have had this question for long that I don't quite understand. What is a qubit? So let's see if Gemini can help me understand that finally. So remember that this is supposed to be for a graduate student. Think of it as lights. Traditional computer is a light switch where each bit is either 1 or 0. I think this is a pretty neat analogy. It's like a dimmer switch. It could be on, off, or anywhere in between. And this is called a superposition. Cool. So you can read this on the notebook. But yeah, so it's asking me if there's any follow-up. So yes, I can send a new message without having to send the history again. Because we started a new chat session. So I forgot to mention that. Instead of generate content, as in here, you start a chat and it'll automatically know that there's going to be context to this conversation to keep track of. So, okay, if the properties of the qubit are inherently different, how can we write algorithms in classical computers? So I think that that's a fair question. I don't think that any of us have a quantum computer on our home. So how do researchers do that if they don't have easy access to one of those? So yes, we could use simulators or specialized languages. I cannot attest to the accuracy of the responses because I am no expert on quantum computing, but like there are a few members on DSI who have more experience about this that could clarify it later if necessary. So yes, this you can see that it already knows that I'm Enrique because it's part of the conversation above. Nice. Yes. If it seems correct, then awesome. So what about if I want to take my notes? I'm a lazy person. I don't like to write down if I need to. So let's get the LM or Gemini to give us a summary about it. Okay, so qubits versus bits. What is the superposition? Quantum algorithms and development. Cool. So, you could change the initial prompt to tell it to be a high school teacher, and use different types of analogies, make this content more accessible to people who are not graduate students, and that should work as well. And the sky's the limit when you're developing chatbots. So this is fun and games, but it actually has an application or multiple applications later on. But I wanted to show also one of the neat features about Gemini, which is code execution. So there are two concepts, and to the one that is widespread, which is the use of tools. What that means is that you connect an LLM to a set of functions that run your computer and execute stuff. For example, and the LLM could generate a Python function, and then you can grab that and execute it on a Python runtime, collect the results, and put them back into the prompt of the LLM to do something else with them. But a code execution is a slightly different flavor of that. What it's doing is that it's running the code generated in Google servers, so you don't actually have to run it yourself, which is quite handy. Say that you're developing a web application and you want to execute code, but you cannot assume that you have access to a Python interpreter on Chrome or on Safari. So you can enable it easily by specifying the code execution tool. And let's see what we can do with it. So I want a Python function that uses a regular expression to detect the URL. And I want to see as a markdown code. So let's ask for it and let's read it to see if it's good. So this is Python's regular expression model, which is good. So we have the detect URL function, a doc string, and the pattern. Just by quickly glancing at it, looks correct. So it could be an HTTP or HTTPS optional prefix. It may have the www prefix as well. And then it's going to have multiple segments repeated multiple times. Yep, repeated multiple times here. That's something. So it must be something.com or something.ai. And it may have a trailing slash or multiple slashes. So the pattern looks okay. And like this is a classic example of something that could seem a little bit hard. And you certainly cannot expect an LLM to execute this deterministically. So I see it working occasionally, but it's not going to be an exact match. That's why you have the automatons that actually run the regular expressions. But nonetheless, this is a valid Python code, so we get the pattern. We are using the regular expression module to run the pattern over the input text, and if there's a match, we get the result. And if there's not a match, then we run none. So this is already part of the chat, so it's on the context. So I want to make a tweak to it. So I want to use name groups for each component of the URL. And as a result, I don't want a match object. I want a dictionary that has each of the elements of the URL. Let's see if Gemini can do those adjustments for us. And yes, indeed. So we get the multiple name groups with the protocol, the domain, the path. So usually that's what you're looking, especially the path is the most important when you're developing web APIs. And then if there's a match, we're fetching those components from name groups and creating a Python dictionary that contains them. So far so good. And so we have an updated function, and on the history of the chat, we have two versions of the detect URL text. So we only care about the second one because it was refined based on our specifications. So let's ask Gemini to run it with the following input. So here we have, the protocol, we have the domain github.com, and the path is this, like from slash all the way to main. So this should match. I'm gonna expect the LM to get it correctly, like exactly. But if it's running code, then certainly is going to do it. So let's see what happens. So the function successfully identified these URL components. Yes, so there's one slight tweak here. As the path only got the first segment, so my question would be like, is it because it bypassed the LLM, or is it because the regular expression is not correctly written? So if you see here, this quantifier is just asking for 0 or 1, and it's ignoring the rest. So I'm pretty sure that it's actually executing this. And one way to verify that is if we pass an invalid URL. It's pretty easy to do that if we replace HTTPS by invalid, because on the first group it's expecting either HTTP or HTTPS. So let's see what happens here. So the result is none. Exactly why, for the reason that I mentioned you. So it's actually quite good at knowing why. So yeah, this you can do that with Gemini, and this concludes our exercise. So Gemini supports much more features. Like it also supports audio. You can actually execute tools, but for tools we need to get much more involved, and there's not enough time on a single session. It also supports long context prompts, as Alan was mentioning, which is also pretty neat. So if you need any of this, make sure to take a look at Gemini's documentation. And finally, something that I want to mention is that sometimes there is some confusion about like what is Gemini and what is Gemma. So Gemma is a foundation transformer model from Google as well, which is open source. And what they do is they provide weights, so you can actually go into Hugging Face and fetch them, run them on your own GPU or your own CPU, and do stuff with it. You can certainly do what we're doing here, but you need to do your own code to interface with the LLM. Gemini, on the other hand, is the product as a web service that you interact with. So you get billed by the token. I am pretty sure that Gemini uses Gemma under the hood, different or a customized, highly specialized, improved version of Gemma, or something else that Google has as their own, trade secret IP. And so you can take a look at Gemma as well. Depending on what you need, it might make more sense to do it yourself, or if you are just interested on extending your own software development using AI, maybe Gemini is a better fit, especially if you have the budget. So yes, this is the end of our Gemini demonstration. And yeah, do you have any questions? Thank you, Alan. All right then. So then that concludes we finished a little bit early this time around. But yeah, so now since we have time, I want to selfishly advertise AI Makerspace. We do hands-on coding with AI technologies such as this. So you can consider this to be a lecture and the Makerspace session to be something like the office hours. To do RAG